density of the field coil and also the armature coil multiplied by a motor constant. Some book put K, some book put Km, somebody put something Ka, something like that. But basically, there's a number which is called proportional constant that depends upon the material used to construct the motor. That is stator, that is armature and field coil, not coil. I'm talking about core material. The type of all those things, air gap, flux density depends on air gap between the pole pieces and the armature. Too much air gap means this the torque produced will be less. All those things will be based on the given number. From that, always you can compute what is the torque produced by motor using the equation. Yesterday we talked. I showed about the equations also. Okay, let me see. Yeah, we talked about it. Finally, yeah, shunt motor. We gave the equations. I think we don't. Yeah. Yes, please.
We have some connectivity issues here. Maybe that is why we joined very late.
No, don't worry. No issue. I'm talking about it yesterday. I understand. No issue. Okay.
Still it is a problem. I'm coming.
Yeah, I'll wait for another 2-3 minutes. No issue.
No problem, sir. No problem, sir. Now we can start, sir.
Okay, very good. Thank you. Okay, so the torque produced in shunt motor is governed by this equation. Okay, and this is they called as a generated torque at the armature because of repulsive force created by the two magnetic fields, armature magnetic field and field magnetic field. Because of that is governed by this one equation. Already I told what this P means: number of poles, number of this one. A is parallel path. This is number of conductors per parallel path. Z. This is the field coil strength. Please note that in some equations they just to say phi, correct? That is shunt coil. That say that in this one shunt motor, the current flowing through field coil IF is fixed once the RF of the coil is fixed. So that means phi f is constant. Generally, phi f remain constant. Okay, that's why they say phi. And the other one is the term is decided by the RA. That is IA, correct? Armature current. So the IA is not constant, correct? Already we know that IA is nothing but V supply minus VB divided by RA. This is going to, but VB is not constant, correct? VB varies from 0 volts to VB max. That is decided by the, correct? For example, the motor supply voltage is 100 volts. VB, this is V supply. VB may be 70 or 80 volts. It will not be 100 volts. VB will be always lesser than V supply. Why? Anybody can tell this? Why it should be lesser than VS? I'll just now wrote the equation.
If VB is more than VS, then the torque will be saturated. Like what I meant to say is, VB is nothing but it is opposing the torque which is being produced.
Yeah, you are 10%. That's what I said. Mark IA equal to what? See, in this equation you have IA, correct? This is all those things are fixed, correct? P is fixed, Z is fixed, phi shunt. As I told you, the current going to the phi shunt or phi is nothing but field magnet that is fixed. 2 is constant, pi is constant. Yeah, these are all constants. What is the variable? IA. IA is varying, but if VB is not there, if VB is not there, what will happen? IA will be also constant. You give a supply voltage 100 volts divided by RA equal, I say 10 ohms. Okay, that means RA, this is 100 divided by 10. So 10 amps current will be going, just like field coil. So then the torque produced is fixed. But in the shunt motor, the IA is not decided by it because it is equation equal IA equal to V supply voltage minus back EMF. Back EMF varies from 0 to some max value, correct? 0 to, it can go up to say 70 volts or 80 volts. So that means the voltage applied, VS, I can say that VS minus VB is called as net V net, correct? Divided by RA. So that means V net divided by, this V net is not fixed. When the motor starts, V net will be same as VS because VB will be 0. Note that VB directly depends upon N. when n equal to 0, that is armature motor is not running. You applied voltage, motor yet to start. Armature is not rotating. In that case, n equal to 0 means VB will be 0. So that means when motor stands in a starting condition, the maximum IA will flow, maximum torque is produced. But as the motor speed increases, the voltage become 0, VB will become 0, 10, 20. Like that, it go to VB max. If I asked you if VB max also 100, what will happen according to the equation? IA equal to 100 minus 100 divided by 10 ohms RA. That means 0 divided by 10, 0. IA will become 0. In this equation, if IA becomes 0, what will be torque? Torque is 0, motor stops. So, when designing the motor, the manufacturer sees that the maximum VB generated by the motor at the maximum speed. The motor speed will vary from, for example, 0 to 5,000 RPM. Or even 10,000, small DC motor can go up to 10, 20,000 RPM also. But industrial, bigger motor may go to 0 to 5,000 RPM, correct? At 5,000 RPM, it may generate 80 volts or 70 volts only. Otherwise, IA will become 0. V net should never become 0. If it becomes 0, IA will become 0. Then automatically motor torque also will become 0. Motor torque means motor will stop. It won't rotate. So that's how it designed. So VB will be always lesser than V supply. Okay.
So can we say that, sir, that the speed limit of the motor will be decided by what is the VV value? Is that right?
Yes. That is one of the reasons. And finally, when you design motor, it is going to do some work. Mechanical work it has to do. I want torque and speed. And of course, the P. Now, what is maximum power it can, that is N into T. Correct? These are three, but torque and the speed of the motor and the power of the motor. Because that is multiplication of torque and this one. So you say this much torque should develop. So the torque is proportional to IA. Torque of the motor is proportional to IA according to the equation. Correct? So this equation, torque equation, you can see that T equal to PZ phi into IA divided 2 pi A. Correct? So all these things are constant. So IA is going to do what is maximum torque it can create. And also we saw the motor speed equation. Correct? Speed equation also depends on what is the supply voltage. And so that is going to do. So these two things will be considered. What is maximum supply voltage you need to apply? So that maximum IA at full speed, at the maximum speed you will apply. So that maximum torque is whatever torque you want. TM is you want that much torque. So at the full speed, the net current, net voltage is such that the IA is maximum for that speed and produce a maximum power and torque.
Sir, I have a couple of questions. Can I ask if you allow?
Yes, please. Yes, please.
Sir, while we are we see drawing of DC motor, suppose like a starter motor we use in auto or like two-wheeler for starting the engine. Is typically DC motor.
Yes.
So, sir, in that drawing, we see the values like rated RPM of the motor. Okay. And so, suppose when we say rated RPM of the motor, what is the physical significance of that? And what will happen if I run the motor beyond that particular speed?
When I say that, yeah, good, nice question, because that is there are two things. The power consumed by motor, P rated, you will see that P rated or motor power rated, and P rated are also called as continuous. Correct? And other one is called max, or sometimes they put as a peak. Peak power, similar peak torque, all this thing, correct? So rated means, for example, I say my motor run at 100 volts, that is V motor supply voltage, or V supply, correct, is 100 volts. And I say that I supply, also say the I motor is 10 amps. And then we say that the P motor is automatically multiplied with these two. VM multiplied by IM, and the number would have given automatically 100 watts. Correct? So while mentioning this PM and IS or IM, VM, they will say rated or continuous. That means if I run my motor, for example, I have a voltage source which gives 100 volts plus or minus and connected to my motor. Right? Rated means I switch on at T equal to 0 time. I can run my motor 1 hour, 2 hour, 3 hour, 4 hour, 10 hour, 24 hours, non-stop. Correct? We know that when motor is running continuously, yesterday I told you there's one loss called copper loss, I square R loss, the IA square R. Correct? There's a current flowing in the armature coil. Of course, there's a current flowing in the shunt coil also. IA square and RS square. This is the power wasted in the shunt coil as a heat. Correct? Field coil, shunt coil. This is the power in the armature. PM equal to this. This is also again as a heat. These two heats, you will see one motor switch on will be your room temperature. As the motor is running, motor is getting hot. Why? This power is lost. You gave, what is this power? This is input power. This is the input electrical power. You gave input electric net power supply. 100 watts you are supplying. This, what do you expect? This is a electrical power. I say PE. P is the motor voltage multiplied by motor current is the 100 watt because this is what input power. But mechanical power equal to motor speed multiplied by torque. Correct? So this is called a mechanical. I say mech will be always lesser than PE. That depends on efficiency. P mech will be 80 to 85% or 75 to 80%. Correct? But remaining what happens? The 20 to 15% is wasted as a heat in armature coil. This mechanical friction in the bearing. Correct? You may supply cooling because later I'm going to talk about various losses, power losses in your motor when we talk about induction motor. Okay, maybe tomorrow, day after, that will show. So these power are mechanical power, friction in the bearings, wind power, that is wind resistance. Because air will be supply inside the motor to cool it. You will see that inside there will be internally will be closed. There will be a small fan to remove the heat generated in the coils. So the air is going. That also there creates some resistance. The motion, correct? It opposes the motion of the rotating armature and the bearing friction. All these things will come mechanical losses. I say the P mechanical losses. So the P electrical minus P mechanical losses will be equal to P mechanical energy, which is we call the P shaft power, which will be around 80, 75, depending on how good your design, friction, all those things removed. Okay. So your question is what do you mean by rated? Rated means I can run at that speed. I say that P motor, you supply this much current and voltage. So the torque produced is a 10 Newton meter and the speed omega to say 5000 RPM. Right? So at this speed, it can run continuously. That is called rated. But when you start, sometimes you need more friction overcome. So the motor is capable of generating. So instead of taking 100 volts, correct, if you apply this one, you can apply little more extra voltage also, 120 volts. So automatically current will become say 12 amps. So the power consumed will be 120 watts. Correct? You suppose your initial friction, something is you want to overcome. What you do? You can apply higher voltage. This is called rated voltage, rated current. But the motor manufacturer say you can apply up to 120 volt for short duration, for 10 seconds, 15 seconds, or 30 seconds to start the overcome initial friction. Correct? So generally initial friction will be high, static friction will be very high. To overcome that, you can apply even little higher voltage. That is called Vmax. They say Vmax is this, but you cannot apply continuously. If you apply continuously, the heat generated will increase so much such that within few hours motor will get overheat and burn. Correct? That is called max torque, correct, or max power and max voltage, max current. You should not run on that continuously. So if on the nameplate, if you see a motor nameplate, they will mention only this rated voltage, rated or continuous rating. That's what you need to run. But for short duration, you can apply higher voltage, higher current. So higher power is produced, higher torque is produced. Motor can overcome additional load also. Okay.
Nandri, sir, Nandri. Thank you.
Okay. Thank you. Okay. So next we will continue this one. Already we talked about VB. Already yesterday I told you TG equal to Km into phi into Ia. What is this Km? Motor constant. In this case, the motor already you know TG already equation is there. Correct? So we have the TG equation. Yeah. Correct? I'm rewriting back once again for the clarity. So here the Km equal to, this is the final equation, short form, correct? Where Km equal to, we know that it is Pz divided by 2 pi A. This is called as motor constant. Sometimes they put just K alone. Some books they put Km, some book put Ka. Don't get confused, but they call motor constant. Once motor constant is there, what is it? So this is why it is called constant? Number of poles in a motor, 2 pole, 4 pole, 8 pole. It can they decided. That is this number of parallel path, number of conductors per parallel path. Z. P is number of parallel path, 2, 4, whatever may be. Pi is constant, 3.14, 2 is constant. So the whole thing become one number. If you know, for example, this is P equal to 2, Z equal to 2, 20 divided by 2 into 3.14 multiply A equal to 2, correct? So if you do that, you will get one number. This is that is already many times motor manufacturers use this number directly, correct? Otherwise, you can calculate if these parameter PZA is given. From this, you can Km and substitute this value here, multiplied by the magnetic flux, a field flux, multiplied by armature current, correct? Armature current. So from that you can calculate. So if I draw the torque versus current, that means what actually it means. This phi also will be many times constant. I told you, correct? Why it is constant shunt motor? We know that we supply voltage. It is parallelly connected. Again, for clarity, and we are applying this 100 volts means same 100 volt is applied across this for this also. Okay, the Vs is going to be 100 for armature coil, and also same Vs applied for field coil. In the field coil, this voltage divided by Rf will given If. So because of that, phi F or phi shunt or phi F, please note that why I'm telling many things is different books say that than just pi. All are same in case of shunt motor equation. We saw the Tg equal to. So this is going to remain constant because you are applied 100 volts, the coil distance fixed. But in case of armature, V net is not going to, V net divided by Ra only is the Ia. Correct? What is V net? V net equal to V supply minus VB. VB is varying. V supply, this is 100 remain constant. But VB varies from 0 to 80. So because of that, the Ia varies. So Ia is not constant. That's why in this equation, final equation, note down in the TG, mod TG or TM, motor torque or generator torque is Km multiplied 5 into this one. This is constant. This is also constant. Only variable is Ia. Ia varies depending on motor speed. Motor speed varies depending on what is the load you are applying, connecting. As load increases, motor speed increase or decrease. So now if I vary the Ia, correct? Ia can be varied by supply voltage also, correct? By varying supply voltage, we can do that. So we see that x-axis is Ia, that is armature current in amps. Y-axis is torque in Newton meter. Okay, so you will see that for the shunt motor, this is shunt motor. Note down. Next today we're going to see the series motor. Okay, so the torque will be something like this. Okay, so this is the 0 to, say for example 100 Newton meter. This current is varying 0 to say 10 amps. For example, I'm saying. So you see that curve is linearly increasing. Okay, this is the TG. Correct. This is TG, subscript G. Okay. But in the shaft, I told you there are mechanical losses, bearing losses, correct? Other losses are mechanical losses. All the torque generated by the motor because of repulsive force created by two magnetic fields, which depends upon voltage applied, current flowing in the coil, and also magnetic property, Km, motor constant, design, all these things, poles, all these things, is not delivered to shaft. In the shaft, it will be little less. I can say something. So this is called as shaft torque. Please see that this may be little exaggerated. It can be something like this also. Depends upon the motor, the mass of the size, correct? The mass of the armature, bearing friction, all those things. So some amount of current, Ia, when current is zero torque, correct? But if the current is increasing, say for example, this is 0.5 amps, this is 1 amps, This is 2 amps. Like this, it goes to 10 amps, correct? So up to 0.5 amps something, even if you give some voltage, current is there, the motor shaft may not rotate. Load position, bearing friction, all this mechanical losses prevents the torque production. Produced torque is not going to be converted this one, correct? In that case, somehow the current over, then only torque itself will be produced. Correct? Torque, even the torque is TG is there, but the shaft torque will be always less. That's what I said, correct? It takes some out of this one. So this is the torque of the shunt motor. The first shunt motor. Current versus torque generated in the shunt motor. Current only depends upon the supply, correct? Or VS. If I vary the VS, supply voltage 0 to 100, automatically the motor current to IA will vary, correct? From 0 to 10 amps max. So the motor torque TM will vary 0 to 100 Newton meter. Then motor speed will vary 0 to, say, for example, 3,000 or 5,000 RPM. So whatever the motor rated RPM, correct? It is going to vary. So this is one thing. Then I wanted then you will also see the motor, if you see motor characteristic curves, that is IA versus TG, one curve, another this, they will say IA versus speed, N in RPM. Motor speed, I can say that motor speed for the shunt motor, the motor speed will be something like this. Theoretically, the motor speed should remain constant. Shunt motor, the motor speed should remain constant. Okay, so the current is varying. They say I naught. When the current is less than this, the torque production is not there. That's what I said. When current is start from 0, so this is 10 amps, correct? So the motor speed, correct? Motor speed, sorry, we are talking about motor speed. This should remain constant, even if you increase it at a no load condition. Okay, but in actual motor, the curve will be something like that. Slightly, it will drop. Correct? This difference should be very minimal. This
Sir,
is
at
called,
no,
this
sir,
is
just-
called as no load condition.
I'm sorry.
No
sir.
load torque, top one. That means there's no load is acting. You are just increasing current. Motor speed remain constant. Shunt motor is a constant speed motor. Because of this characteristic, it is called a constant speed motor. Even though your current vary from 0 to 10 amps, the motor speed will remain theoretically constant on no load condition. But this is a practical motor.
Sir, I have a
Practical-
query over here. I'm
Yes,
sorry.
please.
I have a, can I ask, sir, please?
Yeah.
Sir, when I'm increasing the IA, that
Hmm.
means I'm increasing the power input to the motor, right?
Yeah.
And P is increasing. Now I
Yeah.
don't have any load over there. Okay,
Yeah.
sir.
Yeah.
So if no load is there and I'm
Yeah.
increasing the power, so that
Yeah.
means the RPM should theoretically increase. Why it is doing constant?
Yeah. In the previous slide we talked VB. What happens to VB? That is the beauty of the shunt motor. Shunt motor is a speed. It regulates. Shunt motor regulates its speed internally. Regulates its speed internally, automatically. You need not apply. That is internally, speed is regulated. Okay. We know that if speed increase, what happened? VB is proportional omega, correct? And the torque N is proportional to torque. Torque is proportional to IA. IA is proportional to VB. Correct? In this, all the interconnected. Okay. When motor is not running, when say N equal to 0, VB equal to 0. Okay. That time once the motor start running, correct? If your speed is increasing, because IA you are increasing IA as you ask, automatically VB also start increasing together. Correct? So the net voltage applied to armature always remains almost constant.
Sir, but the question over here is, sir, suppose this VB is internal thing of the motor, right?
Correct.
It's because of Lenz law. Like
Yeah.
what I meant to say. But if the
Faraday's law.
okay, sir. So basically, if the VB is increasing such that that the power input that I'm giving is balanced by that, then where is the like if some load is coming on the motor, from where it will get the power from? If all
see, no load condition, because the maximum speed attainable, correct? This is the max speed, correct? Max speed already decided by manufacturer. He says that our nodal condition, what is the maximum motor speed obtained? That speed is proportional to torque. Torque is proportional to IA. IA is proportional to VB. At this one, I told you that if you apply 100 volts, because of say, voltage you are increasing 0 to 100 volts, because of the current is increasing 0 to 10 amps. If there is no VB, then then speed will go. So this is called self-regulating. That's why DC motor is called speed. It will not go, but the series motor dangerous. That's what we are going to see next. Correct? Series motor is opposite.
Basically, if you apply load, then RPM will decrease. That's it.
RPM will decrease. VB will decrease. Current increases. So current increases, torque increases. So increase the torque will automatically drive the load.
Your voice is breaking.
Okay. Fine. Okay. Okay, we saw this how the DC motor works, shunt motor. Next one, we see DC series motor.
Sir, your voice is lost. I'm sorry.
Oh. Just 1 minute.
It's okay this side.
No, it's okay for us, sir.
Okay. Maybe Roshan should just connect and disconnect something, do maybe at this side. Okay. So next type of motor is the series motor. Series motor generally represented with his power supply like this. You have, this is the field coil. This is the armature coil. This is symbol. Okay. And this is connected to this one. Plus minus. This is my V supply. This is field coil. Because of that, there's a current flowing, IE. Okay. This current is called I series. Because why? From the battery plus the current enters into the field coil. Field coil, one end is connected to battery positive. Other end of the field coil is connected to armature coil, one terminal. Other terminal armature coil connected to battery. So you can see that armature, both the coils are connected in series with power supply. So the same current is flowing in both the coils like this. In the previous case, you know that this coil was here, right? So one current was going. This was the field coil, and there's an armature coil. This is IA. This was I shunt. We said I shunt. This became IT. But now same since both the coil are connected in series. So we say that this is not there. This is the configuration. So current goes inside this is called a series motor. Right? DC series motor is this. Okay. Now we can write according to KVL, Kirchhoff's voltage law, which talks about voltage across a closed circuit. This is a closed circuit, correct? This is a closed circuit. KVL across this one is equal to V supply from the battery equal to I series multiplied by, and this coil has the resistance field coil. We call it a series coil because the series motor RSC, and this one will call as RA, armature coil, correct? So plus RA. Okay, these two are the voltage drop. We say that this is called. So actually, I will write this one. Then VB. VB is back EMF, because here there's a back EMF always there in the armature, whether it's shunt motor, series motor. So I can say that VS can be explained as I series into R series plus I series into RA plus VB. This is the total equation. Okay. Now, we know that I series is nothing but IA. IA and I series are same because same current is flowing from the battery. But that battery current is coming from battery, only who is supplying. Same current, but there's a two different current, correct? Shunt coil different, that depends upon this one. Now the net. So this is called a net resistance. I can say R net of the because both the coils are connected in series. But for understanding, just leave it. Now we know that T motor is proportional to IA and phi. Okay. And now phi means we're talking about the field that is series coil magnetic field created. This here. Okay. Which is the field coil. Field coil is connected in series. That's why we call it as a series coil. And but actually it is a field coil that is in the body of the motor. Okay. And the armature coil is on rotating part. Now, as you increase the voltage, correct? As you increase the supply voltage, I can vary the supply voltage 0 to 100 volts. For example, this motor is 0 to 100 volts. Some motor may 0 to 10, some may 0 to 1000 volts, whatever may be. For understanding, 0 to 100, the I series will increase. Correct? We can say that I series equal to V supply divided by R series plus RA. That okay. And I series equal to IA. Both that is same current going to be same. Now, as you increase the current, as you increase the voltage to the coil, this voltage 0 volt, 10 volt, 20 like that increase. This magnetic phi increases. This magnetic first phi start increasing. I series.
Sir, I have lost your voice. I'm sorry.
Yeah, this time even we lost. I at least. Is it the same case with everyone else? Because even I'm not able to hear, sir.
Yeah,
Yes, I cannot also hear.
I cannot also hear.
Arunachal